This is TempleOS 5-minute random code walkthrough, episode 33, and I'm your host, Terry Davis. Let's see where God takes us. Alt B. And we are in disk 1A. Okay. Read cluster blocks. Okay. Well, this is exciting. This is a cluster is, for example, 32 blocks. A block is 512 bytes. On a CD-ROM, a block is 2048 bytes. Anyway, this variable partition sectors per cluster. On the Red C file system, which is what we're going to, I'm going to demand Microsoft support Red C so that we can eliminate code. Anyway, on the Red C file system, it's one sector per cluster. So this is one. This is an odd routine. It's not reading a whole cluster, but it's reading a certain, let's say the last few blocks of a cluster, or the end of a file is a partial cluster. Oops. I'm gonna find. Let's see where this is. You should get familiar with F. R clusters blocks. Oh, it's used more than I thought. I think it's for the last. Hold on a second. It's for the last cluster of a file. That's let's say the cluster. Let's say the file is 4 blocks. Well, in the cluster is 32 blocks. You don't want to write 32 blocks when it's only a 4-block file. So what are we doing here? This is for F open and F close. I think. What are we doing? Read cluster blocks. I want to see if I use whole clusters and partial clusters, or if I just always use this. Let's see. File read. This is reading a file. It finds the directory entry, and then it should if the I guess maybe I keep reading. Does this read multiple? Yes, it does. Okay. Okay, it looks like it's reading blocks, but it starts at a certain cluster. So it's not just for the last block. The last portion. It's not just for the last portion. So it's calling read blocks, and on a FAT32, on Red C it's contiguous. The files are contiguous, and there's one block per cluster. On FAT32 it has to read each cluster one at a time, And no, that's not true. Well, it does read one at a time. You could read. Anyway, so data is the clusters are at start at offset data. That's a block number, and we start at cluster times sectors per cluster, and we read I, which is number of blocks. If it's greater than a sector per cluster, we trim it to a sector per cluster. So we read a maximum of one cluster. Let's say it's 32 blocks. Then if it's 4 blocks, then we read 4 blocks. If it's 36 blocks, we read 32 blocks. Then we get the next fat table entry. The fat table tells it's an array, and it's an array of block numbers, and it tells the next block in a file, next cluster. So cluster num next. I think I use I have a cache. I keep the fat table in a. This is kind of a funky thing. What I want to do is command Microsoft and Linux to support the Red Sea file system. It's a simple file system with one sector per cluster and everything contiguous. That's what we want, and then we can eliminate a whole bunch of code, and it will be perfect. God said it has to be perfect. By the way, we lock the partition. And if it's going to read from cache, read blocks will try to read from cache if it has a cache for that partition. And then when it goes to the actual ATA read blocks, ATA is where we're starting to get on the hardware. We lock the where do we lock the we lock the hardware. Where do we lock the hardware? We haven't locked the hardware yet. ATA read blocks. I think this locks the hardware, the hard drive. It locks the disk controller. You might have a master and a slave, and it locks it for both master and slave. So if you're reading from cache, it's not locked. Anyway, cache is locked, but oh well, how about that? I was a little bit confused at first about the last cluster, but anyway.